Hey y'all, what's up? It's Miss V and welcome back to another video with me. I am a geometry teacher and I'm here to teach you guys some geometry concepts. So today what we're going to be talking about is using the different triangle congruence theorems that I talked about in my last video to help us write some proofs about triangles and how to show that they're congruent to each other. So what I'm going to be doing today are two-column proofs, and I'm going to go through it as I write the proof. But a two-column proof is basically a list of statements and a list of reasons. And basically, you start off with some given information, so information that the problem already gives you. And usually for proofs, if you look on the screen right now, like in the example I have up, it'll have the given information listed, and then it'll say, hey, you need to prove this for me, okay? So a two-column proof, you always want to start off with whatever is given, and then you want to go ahead and transition or get to the statement that you're trying to prove, okay? The stuff that goes in the middle in the two-column proof changes most of the time. Sometimes it'll be the same, but it just kind of depends. And this is usually the part of geometry that most students struggle with, not because it's necessarily difficult, but because it's different. So in math, a lot of times we're used to doing algebra and algebraic manipulations and that kind of stuff. But now with geometric proofs, they can change. So I can get from point A to point B and go a completely different route than you do, but I still prove the same thing, okay? So the example I like to give my kids is, let's say you start off at school and you want to drive to the store. We'll use, I guess, Target as an example. So when you start off at school, you want to drive to Target. We both may get to Target at the same time or different times, but I may take a different route than you do. As long as we both end up in the same place and we did the right turns to get there, then we're good to go, okay? So today we're going to be talking about proofs. And specifically, we're going to talk about what I like to call, or what are called, two-column proofs, okay? They're called two-column proofs because there are, you guessed it, two columns, okay? So let's take a look at this example here, and I'm going to show you guys how a two-column proof looks. So on one side, you'll have the statement, and you're going to go ahead and draw out your column, and on the other side, you'll have the reason, okay? Let's zoom out just a little bit, okay? So a two-column proof, the easiest thing to do is start it. And the reason why is because the start of your two-column proof will always be in the problem, okay? It's always going to be given to you, okay? So in this case, the very first statement that I have is going to be segment AE, comma, segment BD, and AC is congruent to EC, and BC is congruent to DC. The reason why is going to be because it was given to you. This was already information that was given / provided, okay? So first column, or the first row of your two-column proof, is always the easiest one, okay? It's whatever information is given to you right off the bat. So these examples, I got them off mathbits.com. So if you guys ever want to check out that website, it's a pretty good website. They offer a lot of examples for math. So, and it's for all kinds of math, not just geometry. So you guys can go ahead and check that out. All right, so they already labeled the diagram for us. So AC is this segment right here, is congruent to EC, and BC is congruent to CD, okay? From there, we have to figure out, okay, I know that's true already. They told me that's true. What else can I see in this diagram that is true, okay? And this is where we start looking into all the definitions that I've been providing in my previous videos. So, for example, here, one thing that I noticed right off the bat is that this angle ACB, is going to be congruent to this angle over here, which is angle ACB ECD, okay? Those two angles are congruent to each other because they are vertical angles. They're two angles that are right across from each other, vertical angles, and we already know that vertical angles are congruent. So the next statement in my proof is going to be that angle ACB Angle ACB is congruent to angle ECD. And the reason is going to be because they are vertical angles, and vertical angles are congruent. Okay, vertical angles are congruent. So now from here, remember they were telling me at the end to prove that this triangle ABC was congruent to this triangle EDC. And I just did that right now. So this is where the previous video, those triangle congruence theorems, comes into play, because now notice a side, the included angle, and the other side of the triangles are congruent. So by SAS, or side angle side, I can say that these two triangles are congruent to each other. So now I have proven what I needed to prove. Triangle ABC is congruent to triangle EDC, and your reason is by side angle side. The good thing is you don't have to actually write out side angle side, you just write SAS, okay? So that is how we do a 2-column proof, okay? I'm gonna do one more example with you guys, and if you want to, what you can do is before I start the example, you can pause the video and try the proof out on your own, and then you can go ahead and check it with mine. Just remember that you may not have the exact same thing written as I do, but as long as you're getting from one point to the other and the route that you're taking makes sense, then you should be fine. As long as the things that you're saying, like the reasons and the statements that you're saying are true, then you should be good, okay? All right, so the second example is we are given an isosceles triangle ABC with the base being AC, and we have an altitude BD. So I'm going to go ahead and set up my 2 columns, so statements and reasons. And again, remember your first statement is always whatever information is given to you, and you can just write it exactly as you see it. So isosceles triangle ABC with your base AC, and you have an altitude BD, okay? So there are a couple of new words here that you may or may not have seen. The first one is isosceles, and an isosceles triangle is a triangle. Hey y'all, quick correction over here. So in the video I had said that an isosceles triangle is a triangle that has 3 equal sides. That is false. That is an equilateral triangle. So an isosceles triangle is a triangle with 2 sides that are equal to each other. And in this specific scenario, since the base is AC, that means AC is the longer or shorter side. AC is the side that's not congruent to the other 2. So AB and BC are the 2 congruent sides here, okay? Just a quick correction for the isosceles triangle ABC here. Second statement was that we have an altitude BD. An altitude is basically a segment that you drop from one of the vertices of the triangle. So 1 point from the triangle, you drop a segment going straight down, and since it's an altitude, it's going to form a right angle here, okay? So this is going to be a right angle, and this is going to be a right angle. Okay, that is what an altitude is. So what I'm trying to prove here is that AD, this segment right here, is congruent to CD at the very end, okay? So I have my given statement already listed. The next thing that I want to notice here is if I'm trying to show that AD is congruent to CD, I want to take a look at these triangles on the inside, okay? I want to take a look at these inward triangles. So from here, what I want to notice is that these 2 triangles actually share this side right here, BD, right here. So let me go ahead and mark that off. So since they share that side, obviously that side is going to be the same for them. The side's not going to change based on the triangle. So what I'm basically doing right now is I am separating this into 2 triangles. So I have 1 triangle right here, A, B, D, with this side, and let's do pink here. This side is congruent, and we know that we have a right angle right over here. And then I have another triangle right there, which has CBD. And again, we know BD is the same exact side. Here's the right angle, and BC is congruent to AB. Okay, so I just separated the two triangles. Oops. So now from here, I can say that my second statement is that BD, segment BD, is congruent to itself. And when you say something like that, the reason is because of what we call the reflexive property of congruence. And that reflexive property, it just means that you're saying that one thing is congruent to itself. Okay, so like 1 is equal to 1. That's what we're doing right now. Reflexive property of congruence. All right, so now from here, since I showed that we have, notice this is the right angle, so this side right across from it, this is the hypotenuse. Which means that what's in green is a leg. So now from here, I can actually use the hypotenuse leg theorem to say that those two triangles are congruent to each other. So triangle, and let me scroll up to take a look at it again. And remember, whenever you're saying, when you're labeling the two triangles that are congruent, you have to label it in the right order, okay? So if I start off, I go A, B, D. Notice I went from A to B to D, so I have to go and pass through the pink side and then go down to green for the second triangle. So triangle ABD, triangle ABD is congruent to triangle. I can't say triangle DCB, if that makes sense. I have to follow it in the same exact order. So ABD, I have to say CBD. CBD. And we said that was from the hypotenuse leg theorem. You don't have to write out the whole theorem, just say HL. And now we're almost at the last step. Remember, we're trying to prove that AD and CD are congruent. So now if I take a look down here at my previous statement, just by looking at that statement, I can right away say that AD and CD are congruent because of CPCTC. So corresponding parts of congruent triangles are congruent, and just follow the order of the letters. A, D, this is first, that's second. C, D, first, second. So those are the two exact same segments. And you can even look at it here by continuing to label the diagram. Because if we know that those two triangles are congruent, each of their parts have to be congruent to each other. And that is how we do the proof for example number 2. Alrighty, y'all. So like I said, proofs can be a little bit difficult, but it's okay. Just keep practicing. Look at some more proofs online. Try to do some more on your own. Do practice worksheets, because the more you practice, the easier it gets, okay? So if you enjoyed this video, go ahead and give me a huge like. I appreciate you guys' support every single day. And please consider subscribing to my channel to watch some more awesome content on this. And I will see y'all in another video. Bye.